Hi, everybody. Welcome to the webinar. We'll just give people a few minutes to get in here, and we'll start about a minute after the hour. Thank you. And good afternoon, and welcome to today's webinar titled Optimizing Shop Efficiency with Scheduling, Level Loading, and Inventory Alignment, presented by Epicor and hosted by Metal Forming Magazine and the Precision Metal Forming Association. My name is Lou Kren, Senior Editor at Metal Forming Magazine, and I'm pleased to be today's moderator. Before we get started, just a few business notes about today's Zoom meeting. The meeting is being recorded for archiving, and the recorded event will be posted on our website within the next few days. And we'll let you know via email when the recorded webinar is available for viewing online. Also, all participants in this meeting are in listen-only mode. The speaker and other listeners will not be able to hear any audio from your site during the program. However, you do have the ability to communicate with us throughout this program by submitting your questions and comments using the Q&A box located at the bottom of the webinar screen. Simply type in your question, and you'll also use the same Q&A tab to ask questions of our speakers at the end of the presentation. Now we're ready to begin. This presentation promises information to allow attendees to unlock the keys to a more productive, cost-efficient shop. In this session, you'll learn how to streamline scheduling to keep operations running smoothly, balance workloads during demand swings to maximize throughput, align inventory and MRP controls to cut carrying costs while ensuring materials are always on hand, and walk away with practical strategies to reduce waste, improve flow, and drive greater profitability. Joining us today to present on this topic is Craig Kumpula, Principal Solution Engineer at Epicor. Please welcome Craig.
All right, thanks, Lou, and hello, everyone. So as your host today from the Epicor side and as a Principal Solution Engineer with Epicor Software, Having worked in industry for over 25 years, 18 of that or so with Epicor software, today I want to bring to you a focus from the Kinetic Epicor ERP platform, which, as Lou introduced, specifically around features related to planning, scheduling, MRP controls, optimizing your inventory, and planning around inventory availability. So those are the features we're going to focus on today from Kinetic. When we take a look, first of all, just at Epicor overall and who we are as a software company, Epicor was founded in 1972 with deep roots in manufacturing. That's where we started out for the most part, was in the manufacturing space. And today we are a global company headquartered in Austin, Texas, and doing business in over 150 different countries. And 2.3 million users per day run an Epicor platform. And our solutions, as you can see by our mission statement there in the center of the screen, are the digital foundation for the make, move, and sell economy. And when we look at the make, move, and sell economy, our solutions touch nearly every aspect of manufacturing, distribution, and retail. Epicor has grown from the ground up on most of its core ERP platform systems. And it's also grown by acquiring many key supporting platforms, from financial reporting and analysis to omni-channel order generation and e-commerce platforms, to factory controls, point of sale, supply chain solutions. And all of these have helped to create a solid foundation wherever you might be in the supply chain. And although today's presentation doesn't touch any futuristic plans per se, because statements or implications sometimes can be made, this is just a note of caution. But everything in today's presentation and demonstration is focused on live, generally available solutions that are in the Epicor portfolio today. And if you are in manufacturing, and I think most of those attending the webinar today are, what does your planning and scheduling look like? Are there bottlenecks in your process? Are you constantly fighting for the right resources at the right time? Does it run smoothly, or does it run like this logjam where you're constantly greasing the squeaky wheel, so to speak? The Kinetic platform offers robust scheduling capabilities that are both science, that is real implementable building blocks, as we'll get into, and art, that is synchronizing those building blocks that are part of the platform in a proper manner so that they accurately reflect what is happening on the shop floor. And the goal, of course, is to smooth this process out with careful and well thought out best practices that reflect the dynamic reality of your day-to-day operations. And we could ask a basic question: what drives scheduling? Whether it's setting up your ERP system or just looking at what defines this from the production floor itself, these three areas tend to be the main drivers, which are capacity, defined by the resources or machines or people and their calendars; material availability, what raw materials are needed, are they truly constrained or not, and do I have them available, or how long does it take to get them? And then, of course, the due dates. When do my customers need their orders, or what forecasts do I have in place to meet my min-max safety stock levels? And are there any key priority codes or other drivers which determine which customers we need to service first if there are conflicts? So those tend to be the key areas that drive a successful schedule. And then when we talk about building blocks as they fit into those areas, the science side of it, the elements of the software that can help with that, all point to components that help you build that solid scheduling engine. So capacity, the resource groups and calendars, as we mentioned, as key drivers. Material availability can drive that, finite versus infinite. The production standards that are used in your routings as you go through the operational flow within the plant floor. The bill of material reference capability, the ability to link your bill of materials to the operations that consume those bills of materials. Capabilities within the resources that are defined and what those resources can or cannot do. And other details, such as, of course, the dates, as we mentioned, job priority codes, customer priorities, and so forth. And one of these elements of the science side of it is the production calendar itself. This defines the working days and the hours that a particular resource is available. And another is the resource groups and the resources within those groups. What can potentially constrain the schedule? Is it people? Is it machines? Is it tools? Is it fixtures? Or is it all of these? And what calendar is linked to the resources that I define? This particular view represents a group of resources, which are laser cutters with similar capabilities. And note the ability to link a calendar within that, as well as link my burden rates, both for costing and for quoting, and my labor rates. So oftentimes resource groups, if you will fall into similar categories where I might have a pool of similar labor resources, a pool of similar machine resources, and so forth. And this shows a particular resource within my group of lasers. So now that I've defined the pool of lasers in this case, we can focus on laser 1, laser 2, or however many similar resources that are part of that pool. And note that we can also choose to link the calendar here at the individual resource level, where each laser in this example could potentially have a different calendar. And also note the ability to flag that as finite capacity controlled or not. And we will talk more about that driver a little bit later. And costs can be specifically assigned to the resource or to the resource group. So of course, all things from an estimate perspective, as well as an actual job execution perspective, are going to involve labor and burden costs. And whichever calendar you assign, and again, each resource can have its own, or you could set up a group or even a plant calendar for that matter. But you can also set up exceptions. Which hours of the day is this calendar available or not available? Overnights, weekends, which days of the month are available and not available, and so forth. And your maintenance schedule can also be linked to this. So for example, if you want exceptions on a specific machine because of downtime or scheduled maintenance or even break fix maintenance, the system has the ability to create those exceptions based on your maintenance downtime as well. And now let's talk about scheduling methods in general, backward versus forward. Backward scheduling basically says schedule back from the due date, which normally would be the requirement for the production order that's required from the customer. So the customer would be dictating that, and tell me when to start production. So it simply backwards sequences through the process and gives you a start date. Now you do have controls if these vertical lines indicate due date on the right and today on the left, to allow the schedule to go into the past. Now, typically that's not reality. So if it schedules backwards and it hits today and it can't schedule in time starting today, instead of going back into the past, it'll shift everything forward and say you're going to end up late, even though you had a backward schedule that started with a specific due date. So it'll sort of, if you want to picture a ping pong ball, bounce off the wall and bounce back forward and then tell you when you're going to complete. But the idea is I start with a due date and schedule backwards. And on the other hand, forward scheduling says I'm going to start today, or whatever vertical line date this would indicate, and schedule forward based on the required quantities, capacities, production sequence, times, and so forth. And the system will tell me when I can complete. And there's a number of components that impact that calculation in terms of finite versus infinite, existing load, and those types of things. But you have a choice in which scheduling method you choose. And as I mentioned earlier, resources can be flagged as finite or infinite. And you have these choices for every piece of equipment or every labor resource that you define. And here's some of the pros and cons of the finite approach. Basically, on the pros side, if you see the blue lines, that's my bucket, that's my capacity, and how full is it on a given day or across a given series of time, and I will never exceed that capacity. Okay, if the load is too much for the bucket, it'll just shift things forward and move them out automatically. So the software makes that decision based on priority and need date and the scheduled load. And this can be run in a what-if mode as well, where you're not truly setting up the schedule until you gauge the impact of what that finite schedule may be. The cons, there may be other resources that are not flagged as finite. In other words, they're infinite, and this could impact those. You can end up with gaps in the schedule, so you might not have a smooth, level loaded schedule. And then changing a job's particular date might cause all of the job schedules to change, but you also have some controls over that as well in terms of that impact. Here's some of the pros and cons of infinite capacity, and it's worth noting that this isn't all or nothing. As I already mentioned, it could be very specific to a machine, a resource, or even a person. But because in most shop environments, it does make perfect sense to have some as truly constrained or finite resources and some that are not really constrained or bottlenecks. It could be a mixed mode of some finite and some infinite. Some of the pros and cons of infinite capacity. On the pro side, of overload and underload, overcapacity and undercapacity. Again, you can see if my bucket is blue, it will overfill the bucket, so to speak. But there's ways to visualize that and control that, and you can do what if scheduling around that as well to gauge the impact of that change. The planner is the ultimate person that's making that decision, not the system. The system will simply look at each job as it's scheduled, as if it were the only job in the schedule. So it'll honor how many hours a day and so forth, but only within each particular job. It won't recognize the other jobs that might already be in that bucket. So changing a particular job does not necessarily disrupt the entire schedule. On the con side, again, it's not automatically level loading resources here as well. It can be more manually intensive, although you do have more control over the process. And it does allow you to build in queue and move time, but depending on that, that can end up with some irregularities in the schedule as well. In kinetic, it's jobs, either real jobs or what we call planning jobs or unfirm jobs that drive production scheduling. And there's a few different approaches on how these jobs get generated to reflect what is actually going to be built. And those job creation options can be manual, in other words, driven by an actual sales order. So a sales order would drive that demand and tell you to build it. This works well in a just-in-time, make-to-order type of environment. or they can be created in a more semi-automatic way through MRP, where MRP is actually generating the work orders for you, but they're in an unfirm planning type status. So they're not real jobs, they're planning jobs. And a production planner then chooses which ones to firm up and manage as the actual released jobs to the shop floor. And then there's on the right, the fully automatic, the more hands-off, where production is so fluid, or you have dedicated work cells with predefined outputs or products that are being produced in that cell on a very consistent basis, where all you want to do is record what is produced on the back end. So there's no job creation on the front end. There's really very little pre-planning, although you can pre-plan what you're building to meet that fully automated Kanban approach. But any mix of these can work well in a mixed mode environment where you're not particularly locked into one approach or an all or nothing approach. You've got great flexibility in how you set up various jobs and items to meet your plan. And defining your MRP approach, which again, this is the more science, practical side of it. Basically, MRP is going to be looking at actual orders, but you might have to decide, well, what should my forecast be? Or what should my min-max safety stock be, both for finished goods as well as for component level. But in short, MRP will examine all of the parameters that are set up in the system and essentially tell you what to build and what to buy and when. But of course, behind that, again, when we think of the art of that, defining all the appropriate parameters can be a very real business challenge. And this could be based on things like historical performance or any number of factors. And also, let's not forget the production standards themselves, the accuracy of defining those production sequences and how much time it takes to go through a particular routing step for a particular product are key drivers behind the overall schedule and how long it would take to fulfill an order. And then there's a concept here called calculate the global scheduling order. This process actually will look for each job's best end date, and then the system compares the end date to the requested by date to determine if it's early or late. And then this is multiplied with a priority code to determine the proper scheduling order sequence. So this is typically used in the finite scheduling process. And you do have the ability to override that scheduling order as well. So the system will use this sort of logic to come up with the best sequencing of your jobs and then give you the ability to intercept that if you so choose. And then when we look at the global scheduling process itself here again, it will reschedule open engineered jobs. So it's a program that looks at those priority codes, determines which jobs should be scheduled when, which jobs go in front of the other jobs, and so forth. And then all of those jobs are placed into that schedule in that particular order. And again, this can be done in both the actual or a what if mode. When art meets science, that's where it comes to things like managing the exceptions or refining some of the details in that process. And Epicor Kinetic ERP provides many views that can help you with that. For example, in an infinite approach, as I alluded to earlier, there's something called the overload informer. This helps you determine where the bottlenecks are and can help you decide where to allocate your resources or whether to add another piece of equipment or bring on another shift and so forth. But then we have visual scheduling boards or Gantt chart views, many different types of Gantt chart views, both at an individual job level as well as at a resource level, single resource or multi-resource views. And then those can be complemented with other dashboard views using Epicor's comprehensive tool set. So for example, the Business Process Manager or BPM tools allow you to define your own event condition actions and alerts processes around things like notifications and notifications of late jobs and what things you want to bubble up to be visible in certain dashboards and so forth. And all of these can deliver real-time or near real-time information in a single or multifaceted view. And we'll get into some actual examples here shortly. And here's some screenshots of some of those examples. But again, we'll look at some live capabilities as well, where they can be more graphical in nature, showing like the overall bucketed hours that are available across my plant or within specific resources, or simply summarizing my loaded hours in various parts of the system. But the end goal is, of course, for everything to flow in a smooth and consistent and controlled manner. And resolving those bottlenecks is never easy, but with the range of tools that are available for you within the Kinetic platform, it can help you to improve that throughput and on time and on budget performance. So let's move into some live aspects of the demonstration. So what you're looking at here in the background is an actual dashboard view. That dashboard view is something that's it's one of these tailorable views in the system where you can bring to your attention, no matter what your role is within the ecosystem. In our case, obviously, we're focusing on planning and scheduling. I can bring the information that I need to see and what's important to me into a real-time view or a near real-time view, depending on the source of the data. And just a quick high-level explanation of what we're looking at. These dashboard views can be built off of queries, which are just refreshing at a regular interval. So I would say these are within seconds of actual real time, or the one on the right, which is looking at manufacturing variance dollars across the board. This is a business intelligence view that's looking at a compiled source of information that could be ERP data or other historical data. And maybe my refresh rate is less often, maybe every 10 minutes or once or twice a day, or you're choosing, but it's tending to look at longer periods of time and more strategic analysis as opposed to real time. Now, today we're going to focus more on the real-time views and what's available from a planning and scheduling perspective as relates to load and capacity. So you'll notice that my dashboard has a lot of options for me. Some can be shortcuts to drill into specific parts of the system, or they could be these graphical views. The full menu is this teal or blue ribbon here on the left, where I have access to the entire menu, which is searchable. So depending on my role, sales, service, production, I can set my own favorites for any of those menu items. But typically I'm going to see the items that are related to my role within the system. And then I also have the ability to search data. So whether it's a specific job or a purchase order number or a specific resource that I want to look up or a customer, I have instant data access here to do a keyword search across the organization. Again, dependent on which data I have access to as a user. Towards the bottom, I have a communication tool called Epicor Collaborate. And this is a real-time communication tool that can be bringing multiple pieces of information to me. It could be data that's shared with me from other users. So you can see I can use it as a chat in regards to just communicating around a customer or a specific quote or a specific order. But it could also be subscription-based information. where I'm telling the system that I need to receive notifications around certain conditions and actions. And there's rules that can be defined here around customers, orders, shipments, jobs. If I click on jobs, you can see I've got a handful of rules here, and we're not limited to these, where you can actually prescribe in a more proactive way to be notified when these conditions happen. And then based on that condition, it will show up in your dashboard or your stream as either an action item or an FYI type item, where depending on what it is, it can also bring the linked information to me. So if I'm communicating around a specific job or a project or a customer, notice it brings a hashtag with it, and I have the ability to drill right into it from here. So again, very flexible in terms of access to information or communication within the system. Now, if we go back to the dashboard here, you'll notice that I have two other tabs open, and I'm going to use this to kind of jump into some specific part setup details, because the building blocks of what we talked about in terms of science and art and where art meets science, a lot of that really stems around how I define my parts, my manufactured items, my purchase components, and so forth within the application. Now, I will note that we are looking at part setup, part master, but this does not mean that everything you build or buy has to be in the part master. We are not inventory centric in that regard. The Epicor solution is very flexible in terms of building things to inventory, building things to order, and so forth, and not even having to define part master if you don't wish to. And we call that concept part on the fly. But because we're looking at regulated planning and MRP controls, I'm going to focus on inventory controlled items. And I'm looking at 4 different MRP controlled items. And I'll just point out a couple of parameters around each of those. So this MRP 100 LT, it's a machine manufactured lot driven part number that I've set up in Part Master as manufactured. And if we look at the details tree here on the left, and I go to my site locations, I'm logged into Epicor from the Chicago site, but I do have the ability to have multiple sites within my organization structure. So if this same item is going to be built in another site, I can simply add that, and maybe I've got an Evanston or a Rockford site, and I want to set up different controls or different costing methods for that within the same database structure, but a different site location. I certainly have that capability. But today we're going to focus just on Chicago. So if I drill into the site parameters for this lot controlled part, you can see that MRP is flagged. I've got a planner code that's responsible for this product. And if I look down here at the inventory section, I'm building to always have at least a minimum of 200 on hand. Now there's kind of beyond the scope of today's conversation, there is the ability to drive what my min-max safety stock levels should be from historical values. So this information can be fed from the history of this part and how it's performed in the past to help you come up with the proper planning parameters. And again, that's a more extended discussion, but that capability is there. Otherwise, planners, based on their own internal knowledge, can certainly just input these parameters as well. So this one's a manufactured part, 200 minimum on hand. And if I look at my other planning parameters, I'm also telling the system that it's most efficient for me to build at 100 at a time. Okay? And there's plenty of other planning parameters here. We won't get into all of those today. But this is part of that art meets science MRP control that helps the system determine when it sees demand, how should I react to that demand and build for that demand. And again, we're looking at a manufactured part as an example. Now within that manufactured part, if I go back to the product details, there are also revisions, either one or more revisions that control this with effectivity dates. the Epicor Kinetic platform allows you to have as many different revisions as you want. And you can even have more than one active revision if you want. But MRP will look to the revision, the current most effective revision, or based on the due date of the order, for example, look at based on the effectivity compared to the due date. And it will look to what's called the method master. And I'll drill into the tracker here for a second. And that method master has operations and materials that fit into some of the things we talked about earlier. So the operations list, and this one's pretty simple. I've got 4 operations and 2 materials. But how long it takes to saw, mill, deburr, and do that final inspection is going to drive the schedule. And notice we can have different labor entry methods to actually report our actual time. So the standard is going to be our estimated time, and that can be any number of different formats, fixed hours, hours per piece, pieces per hour, etc. And the labor and burden costs can be backflushed, meaning I don't have to report them. It's just going to apply a standard to it automatically. Or I can report time and quantity or quantity only. And that reporting process will track the actual costs as I execute on the production schedule. But the planned schedule is going to come from that production standard that's set up here. And then within it, you're going to see the resources. So remember earlier, we had the ability to define resource groups and resources. If I look at my resource list here, this is pointing to my sheet metal workforce. And if I look at the saw here, it's pointing to the saw group. There's a ton of flexibility around how you define that. It could be looking for a certain capability. It could be looking for a very specific resource. So it could be saw number 1, for example, instead of grab any saw from the pool. And that's going to depend on your process. Oftentimes in regulated industries, we see specific resources spelled out because that process has been proven capable against a specific machine, for example. And I could call that machine out as the specific machine that needs to run this particular product for this revision of that part. Okay. So this is where all of that's defined. And then if we look at the material side of it, we're looking at some round bar stock material here at a specified quantity, how much is needed, what unit of measure is needed, and it's really on a quantity per basis. So the material side of it also gives me controls within the system. If I drill into this particular material setup in part entry, you'll notice a couple of things about this. One is it's purchased, so the system knows that I need to buy it. And there's a whole bunch of parameters if we look to the overflow menu here in terms of approved suppliers, managing my parts or supplier price list, and so forth that come into play here as well. But MRP is going to treat this as a purchase item. And then over here on the right, it is constrained, which means the availability of that material can constrain my schedule. And again, that's a parameter that you have control over. So there's lots of parameters, settings, and controls that can help you drive towards the most accurate schedule possible. If a material has a longer lead time and is more limited availability, I would argue that's a true constraint. Whereas if not, even if I don't have it in inventory, I can get it pretty quickly, I probably wouldn't want to constrain my schedule around that. So again, you have those controls. So we sort of drove into just one example, this lot controlled part. We're building 100 each of those at a time as a minimum build quantity. Just to quickly compare some of the other controls, this one's a non-stock item, which means it's flagged as non-stock. Doesn't mean I can't have stock, but that's an MRP driver that says, let's produce it as a just-in-time, only when I see demand. And let's do make direct. So this is a make item, and make direct means if I see a sales order out there, MRP will generate the planned work order and link it directly to the sales order. So I'm producing it not to inventory, but just to that order quantity. And then at the site control, I have a lot of the same kind of parameters here. within the site management, I have the ability to set up any min-max safety stock levels. This one's at 0, or any advanced planning controls around multiples and so forth. And none of those are, none of those have quantities. So basically it's just in time. Whenever you see a bunch of zeros, think just in time. I'm just going to produce it when I need it. Okay. And a couple other quick ones. MRP 100 days of supply. I've just got a different machine part here with some different planning parameters. This one is build to inventory. But if I look at my planning parameters here under my site controls again, I've got a days of supply value of 7. So essentially what the system is going to do is if it sees demand, which could be orders or forecasts, look for the next 7 days worth of demand and fulfill the supply to meet that, rather than if there's one today, one tomorrow, one the next day, let's just automatically combine it for the next 7 days. So you'll see a different reaction by MRP in how it builds the item to meet that demand. And then this last one is just simply a stock part, machined item, build to inventory. And again, it has its own planning parameters here under my Chicago site to say 0 min-max safety stock. So it's, again, think just in time when I see that. And under my planning parameters, days of supply of 7 here as well, but it's to inventory instead of direct. Okay, so that just gives a flavor of different ways I can control the setup of the item. If we look at how now from a planning and scheduling perspective, how does MRP treat this? I'm in a screen here called planned work orders, and I've already run MRP, and I've already filtered this down to just 3 of the parts that we just looked at. Our lot parameter part, 100 at a time, our non-stock item, just in time, only for orders or forecasts that show up, and then my stock item. So those are 3. And you can see MRP has created what we call unfirmed jobs at a specified quantity. And there's a whole bunch of other jobs that MRP is telling me to do too, but I've just filtered this down to just show 3 of them for now. And one of the tools that can help you analyze what MRP is doing is to take any item, and I can do this at a top level, or I can do it at a lower level within the component level, and that's called time phase. Think of that as a snapshot in time of what the system's telling me to do. Okay. Now, if we look at the receipts column, this is what MRP is actually building up to, and you can see it's creating all these MRP jobs for me. If we look at the requirements, that's the demand column. And you can see my requirements, for the most part, are forecasts. So I've got forecasts out here for this item. But you can see how MRP is telling me when to build. 10-1, I need 100. I need another 100. Well, why didn't it just combine it and tell me to make 200? That's because my lot size is 100 and my maximum build quantity is 100 at a time. So it broke it out into 3 different jobs to meet the demand, to get me up to 301 on 10-1. And then it starts to look at future demand from there and future build to meet that demand, again, at those specified quantities. So you can see how MRP is regulating not only the build dates, but the build quantities to meet that. I'll leave that screen open for a second and change to a different part number, our non-stock part number. And this screen will auto refresh for me to show my non-stock item. And you can see in this case, I've got receipts coming in here telling me what to build, but I'm not limited to only be 100 at a time. I can build at any quantity. But my requirements are my forecasts for this item, and MRP is looking at the soonest build in order to meet that requirement. Now, in this case, my first forecast is 10-1. It's telling me the soonest I can get anything built is 10-2 to meet that 25. Okay. Then it looks ahead and says, okay, we need to build 35 on this date to meet this forecast, 90 on this date to meet this forecast, and so on as we go out into the future. And each one of these is a planning job that has a specified schedule, which we'll take a look at some other views for it. But again, the takeaway is how much do I need to build? And when do I need to build them? Based on the parameters that are defined for this item. And then one last example, this is that machine parts stock item example. It's telling me to build 88 here in this case. If we time phase that, there's my build for 88. You can see it's 2 days past my forecast date. That's the soonest I can get it based on MRP. And how does MRP know that? It's because it's constantly looking at capacity and material availability to tell me when that soonest supply can be met. And now if we take that particular job, this build of 88, you can actually see it's combining 2 forecasts. So it's picking up the one from 10/7 as well as the one that's behind my planned schedule here for 33, and it's combining. I'm saying one build for 88, but we can't have it till 10/3. It'll be ahead of this forecast, but it'll be behind this one. Okay. And that's a planning job. If we scroll to the right here a little bit, that's actually in the system in a planned or unfirm state. So I'm going to drill into that so we can dive into it a little deeper and understand why it's telling me to build on this date, and what some of the constraints are in terms of how we've defined our schedule capacity and our material availability. So if we open that up, this is a build for the MRP 100 SK stock part. You can see the demand here is make to stock. It's coming from those forecasts that we saw in time phase. And it's telling us to build 88, even though it was required on 10/1, because that was our forecast. And the same would be true if it was a sales order. If it was a sales order due on 10/1, it would have the same results. But I can't start this until 10/2, and I can't complete it until 10/3. And that's why it's showing up the way it is in time phase. How do we know that? Well, one, I trust MRP and I know the parameters I set up. But if we drill into that job assembly in a little bit more detail, we'll start to see how the system is bringing this together. First of all, when we look at our operations schedule, it's telling us we can't start until 10/2. Well, why wouldn't it tell us to start earlier? And there's going to be usually a number of reasons why. One could be a capacity constraint, where that milling operation has machines, tools, people, etc., that are not available on that date because of other priorities. Or it could be material constraints, where this material has a long lead time and I don't have that material available. Now, in my case, I already know the answer because I set it up. But if we drill into time phase on the material itself, we'll start to see the answer here. I don't have anything on hand. But the system, because it's picking up that approved revision method of manufacture bill of material detail, even though I haven't done anything other than put a forecast in, or again, it could be a sales order, it knows how we build that item. And it's saying, you need these materials and you need them on these dates. Now I could put rounding factors in here. If this is bar stock, I'm probably not going to buy 0.13. I could have that rounded if I want, depending on how I set up that material. But it's telling me to bring in 141 some odd feet of that material on this date. And the soonest I can get it is on 10/2 because of the lead time. And you see that lead time over here is 7. So it's factoring that in. And because it is a constrained material and it's needed on that first operation, I can't even start my job until the material gets here. So it's factoring all of those in place when it looks at both the time phase availability of the material and the capacity availability on the job schedule. So if we look at the job itself and the schedule of the job now, and I'm going to go into my job scheduling board. So again, we have a number of different types of scheduling board views, as we saw in the PowerPoint. There's my mill deburr and final inspection. And if I click on the job, and I can zoom in on days, weeks, months, or years, depending on how long running that job is. But you can see it's scheduled to start on 10/2 on a certain date, but it's late. The red bar is telling me it's late. Why? Well, it's the material. I can't start this job until the material gets here. So that's when it's scheduled my milling operation to begin. Okay. Well, first of all, at a glance, I can see I also have a gap in the schedule between 10/2 and 10/3. And that could be a number of different reasons. If we expand that out, I've got a machine here, my HM4 milling machine. That's the only resource that's being scheduled to do the milling operation. And it could be that that machine is not available until 10/2. That would be one of the constraints here as well. But it could also be that depending on how I set my shifts up, that machine is offline until a certain hour of the day of the next day. So all of those are going to be honored by MRP when it starts to drop things into the schedule for you. Okay. Now we're only looking at this particular job, so we can't see all of the other things that could be impacting this job. And that's where some of the other views come into play. So when we look at, I'm going to expand another operation here. Maybe the deburring operation was a constraint and I can't start it until later in the day on 10/3 because this one has two different constraints on it, my workforce, my machining workforce, and my deburring tumbler machine. Both of those have to be available. And you can see they line up here on the schedule to start. And I could drill to the minute of the day if I want to, but to start at a specified time on October 3rd. And the capacity of those could be part of the question. So to see that at a more, if you want to say, high-level view, where I'm looking at more than just this single job, that's where some of the other scheduling boards come into play. And there's a lot of ways I can look at it. I'll point out a couple here. One is the multi-resource scheduling board, where I can filter on just certain machines or certain groups of machines, or whatever parameters I want to look for here. If I hit the search option, you can see I've got every resource here, and I might be looking for just certain categories of resources, right? I've got some that are defined as machines, cells, persons, fixtures. You can define your own resource types here. And then based on that, I could sort and group, well, maybe only show me certain types of resources. Drag and drop that up. And now I can filter that down and say, you know, I only want to look at my tumblers. So let's take a look at my tumblers. And I only want to look at my workforce resources. So I can pick and choose any resources that I want to look at the overall load for and bring them into my Gantt chart view. I can also pick the date range of which I want. And when I hit view schedule, now it's going to show me not just the one job, but everything that's scheduled for those resources. And you can see it's pretty tightly constrained. I could, again, zoom in much closer here down to the minute of the day, but my MRP jobs are the ones in blue. And you can see they're pretty tightly constrained in terms of jobs that I've already got in the schedule that are taking up white space on the dates in question. So the multi-resource view can give me more that higher level view of my schedule on one or more resources at a time. And then there's a couple other views that I'm going to point out here, and then we'll open it up for questions. The resource load can be individual, where I can pick and choose just a specific resource. Tumbler number one, horizontal machine number two, etc., where I can pick just that resource and show everything scheduled. Or I could look at more of a graphical view. So the one on the right is just loaded hours. And this is overlaying my machine shop floor. So you can take a graphical view of your floor and overlay that with your milling operations. And I can see how many hours are loaded in each of these work cells. So that's kind of that high level load visibility. And then one on the lower left, this is looking at individual resources, and you can see it's cycling through. There's my laser cutter with my bucket. My bucket is never overflowing. Green is the capacity, and everything's under capacity, right? Because it's finite. It's just going to push things out late instead of overloading that work cell. And as I cycle through, I might have resources that are over capacity, under capacity, or at capacity, depending on how I've defined those. So this is looking at specific load over a period of time, over cycling through a specific group of resources. And then another one is more of a dashboard view. I've got one called 10-day capacity. I kind of like this one because day 0 being today, and then day 9 being 10 days out, as I'm looking at my resource groups or even the specific resources within them, I can see how many hours are loaded each day. So today I can see I've got 23 hours of load on this particular assembly bench number 100 resource, and so on as I look down the list. And I do have the ability to summarize that as well. So if I turn on my summary view, I can see how many hours are loaded across the entire plant, or a subset of resources. I can pick and choose what I want to filter by here for today, for tomorrow, the next day, and so forth. And you can see when we hit the weekend, none of my resources are scheduled for the weekend. So if I'm over capacity on certain days, certainly might make sense to open up a weekend shift and make some of these resources available on the weekend and run a what if reschedule and see the impact of that. That might be a scenario I run through. Okay. And as I select, let's say this assembly bench 100 resource, it's also going to show me at the bottom here what parts I'm building, what jobs are in question to utilize that resource, and what the time is and how many hours. And now you can see other factors come into play, like priority codes. So a job with a high priority, for example, the system's automatically going to slot in front of a low or a normal priority job. So again, lots of ways to visualize the schedule based on all of those different parameters that we talked about. And to conclude this conversation, when we look at the overall process, again, the goal being, I'm going to back up a couple slides here to where we ended off, to have everything flow in that smooth and consistent and controlled way. That's the goal. But you can see how when we say art meets science, there's a lot of flexible tools that can help you drive you to that overall goal point. So Lou, I'll open it up here for questions.
Well, thanks a lot, Craig, and especially at the end there, seeing so many powerful tools for, assembling, identifying, viewing, and ultimately acting on all those constraints. There's a lot of power in there, and I think that all falls under that advanced planning and scheduling umbrella. And maybe if you can just give us a quick sum up of APS.
Sure. Yeah, great question. In fact, I'm going to back up a couple of slides here. Bear with me just a second, because for the sake of time today, I really didn't have everything turned on. But I'm going to unhide one of my slides here because it actually talks about what advanced planning and scheduling is. And that can mean different things to different companies. But in Epicor terminology, it really means you can have as many resources as you want. Typically, it's going to be one or two, a machine or a person. But if you want to add a fixture or other things, tooling and so forth, you're not limited to having one or two resources. That ability to set specific materials as constrained. There's a concept called non-time constraints. In some cases, maybe we're talking an oven or a paint booth. There's other things that constrain the schedule besides how much time it's going to take. Mm-hmm. So we've got some parameters for that. And some of the views that we looked at really are leveraging APS, like the multi-resource scheduling board. There's also a real-time capable of promise and order entry that is sort of a mini MRP from the sales order level, where it uses all of these parameters to help sales and customer service try to determine, well, when can we meet the requirements of this order date. So those are kind of the primary features around APS.
Okay, thank you.
Mhm.
And also a question here, how does the system account for unplanned events such as a tool breakage?
So unplanned events, tool breakage, great question there as well. And the answer to that is it depends. If you're utilizing the maintenance module within Epicor Kinetic, as I mentioned earlier, maintenance downtime does factor into the schedule and does create an exception on the calendar for you based on that maintenance. So even if it's break fix, as long as that resource is called out in that break fix, saying, okay, I'm fixing this resource, therefore that resource is going to be utilized, that exception gets put into the calendar, or scheduled routine maintenance as well. If not, then of course you can always go into the calendar and manually put your exceptions in place for when you know that machine is going to be down.
Okay. And speaking of the calendar if it could be assigned to every resource, would that include labor such as personnel? And if so, how does that relate to the HR calendar?
Yeah, good. Another great question. So yeah, absolutely, it can relate to labor and personnel. Oftentimes our customers are looking for, okay, I've got labor people defined. Should I define it as a pool of labor? Should I set up my resources as specific people? Those are the kind of questions that come in with that. And then defining their days off and their holidays and so forth. And you certainly can do that in the calendar setup where you're defining a resource as, in our terms for our demo guy, John J. Labor, it could be a specific resource. So you link that resource to the employee master, and then you define in his very own calendar his working days and his off days. You certainly can take it to that level. So if that's something that you wish to define and set up in the system, that's certainly one of the ways to do that is to break it down to that individual.
Thanks, Craig. And one more detailed question here before we hit the top of the hour. If there is a purchase order for an item that's critical to the production process, can the delivery date of that order be a constraint to the schedule?
Great question. Yeah, we saw how the system looks at constrained material based on lead time and the lead time availability. In the case I showed, we didn't have the inventory and it takes 7 days to bring it in. And it certainly constrained the schedule around that 7-day lead time as the soonest available and scheduled it accordingly. The same thing can hold true to a linked purchase order. So we have the concept of what's called purchase direct, where you can set up a PO to buy that material directly to the job that requires it. Doesn't have to go through inventory. And then based on the schedule or planned receipt date of that purchase order or available date of that purchase order or promise date by the vendor, it can look at that as being the true available date of that PO, and it would work the same as the lead time. It'll look at that availability date as to when that material is going to get here and then schedule it accordingly.
Okay. Well, thank you, Craig. And if there are any other questions or if you want to get in other details about software, you see on the screen there, manufacturing at epicor.com. Please address those questions there, and the team at Epicor, I'm sure, will be happy to talk with you about it. So with that, thank you, Craig, and thank you, Epicor, for that informative and detailed presentation. And thanks to our audience for attending today. We hope you found it to be valuable. And once again, an archive of the program will soon be available. When it's ready, you'll get an email from us. Then you can review what you learned today and share it with others within your organization. You may close your browser now. Have a great afternoon. Thanks, Craig.
Thank you.